Good evening, everyone, and welcome to the Galbraith Building at the University of Toronto. My name is Stephen Johns, and I am a Student Recruitment and Transition Officer with the Faculty of Applied Science and Engineering, and I am joined this evening by two special guests to talk with you about engineering. I'll have them introduce themselves.
Hi, I'm Parisa Najafi. I'm a fourth-year student in materials engineering, and I did PY at Celestica. I will be going into consulting upon my graduation shortly.
Hey, I'm Kinor Chattopadhyay. I'm a professor at the Department of Material Science and Engineering, and I started at the University of Toronto about 3 years ago as an assistant professor. And before that, I used to work in the private sector in a consulting environment. And then I decided to come here and teach all the smart people on campus. And it has been a very fascinating journey for me.
So we're going to delve a lot deeper into the program over the course of the next 30 minutes or so. But before we do that, quick house cleaning note. This is a presentation about materials engineering. This is not an admissions presentation. So if you have questions regarding admission requirements or your application to U of T engineering, please post them in the chat. My colleague who is off camera is answering all admission-related questions live as we speak. And she'll also be giving you the contact information for the office so that if you have anything else that you need to know later on, you can follow up with us directly. What we are here to talk about tonight is materials, and we're going to talk to you about the experience as a student and also the experience from a researcher in the program. U of T is a world-renowned faculty known for leading-edge research and discovery. Regardless of the program you choose, you're going to have access to our top-ranked facilities and faculty, as well as to a curriculum that is constantly evolving. We offer the most multidisciplinary engineering program in Canada. We really give you the opportunity to tailor your studies and to add breadth and depth as you see fit. So as a way of leading us into the topic, maybe you could talk about how you got into materials engineering, because it's not one of the ones that students tend to know a lot about in high school. So how did you come down this road?
So during high school, I really liked chemistry, and I also liked physics. So in order for me to choose the right one between chemical and materials, I really had to narrow down on the physics part, and I really liked math as well. So materials was just the combination of all of these things that I thought really interested me when I wanted to enter university, and engineering for sure, because it's just the application of science, not just theoretical. You can go out in the field and apply this. So that's why I chose materials.
So how would you define materials engineering to someone who knows nothing about what it is?
So materials engineering is basically the study of the atomic level of solid state matter. So anything from forensic biomaterials to simulations of materials. This is what encompasses the field of materials science.
What do you think, Kenora? Did you give an A for that answer?
Yeah, excellent answer. The thing is that, like she said, going into the atomistic levels, so understanding why a material behaves a particular way, like why steel is strong, or why a door which is made of wood has certain properties, right? Why a particular type of paint is waterproof, or why a certain jacket is waterproof. These questions about all the materials we see in our everyday life.
Yeah, I was going to say there's a lot of readily obvious real world applicability to this.
Oh, absolutely. And I think the beauty about materials, like you mentioned correctly, that not everybody knows about that. The thing is that whatever you deal in with life every day, starting from the morning till you go to bed, you're dealing with a myriad of materials all through the day. And why are you choosing particular steel for a car or a particular metal alloy for your iPhone? So all these whys, you will through your program here, you will be actually, when you graduate, you should be able to answer the whys.
So basically, materials engineering is all around us, and we just maybe don't know it, but it's everywhere.
Yeah, so that was my thought exactly when choosing between all the different engineering disciplines, where mechanical and chemical, they're focusing on the application. You're focusing on why would you choose this for the application, and it goes into the material in more depth and detail.
What are some of the unique opportunities available to you as a materials engineering student?
So the opportunities vary from biomaterials research to simulating processes and simulating, Professor Kenora can tell you more about the simulation part. to anywhere from consulting and business. It's very vast, and you can actually choose to go anywhere. Forensic, research and development in companies.
Well, and Kenori, before we came on the air, you were talking about some of the ways that you've taken this training to some really sort of probably unorthodox in the minds of certain people. Pretty unorthodox ways. Do you want to talk a little bit about that for the camera this time?
Yeah, absolutely. I mean, look, I think like when we're talking about opportunities for materials engineers, the thing is that if I look at where our students are going, it ranges from anywhere from a medical imaging device company to somebody producing steel, like in the Hamilton Steel Mills, or it could be a consulting firm, it could be a financial firm. So the thing is that materials is so interdisciplinary that I think that makes it unique. I mean, me being a researcher, like you mentioned, we are a very research intensive university. I mean, I collaborate with my colleagues in mechanical engineering, and chemical engineering, electrical engineering. And I think that really makes us unique. And we are a program where all our students are going different sides of engineering, and I think we are actually holding it together, all these engineering disciplines.
Well, and I think too that underscores an important point that engineering is by nature a multidisciplinary profession, and
Absolutely.
you can't do one aspect of it without at least knowing what the others are doing as well. Let's talk a little bit about the flexibility of the program and how students can customize their materials degree. What areas of focus are there for students? Can already want to answer them?
Yeah, absolutely. So look, I mean, okay, it's a 4-year program, right? So people start in their first year and they start with the 101 type of courses, right? Where you understand what is really material science and engineering. And then you advance in your second year and you start learning things like why materials behave in a particular way. So why steel is strong, or why wood has certain properties, why polymers have certain properties. You're also understanding microscopy techniques and characterization, like how would you, so you can answer the whys, but you need to know what's inside the material. So really go to the atomic level. Then you are also learning things like how to, any company which is producing metals or plastics, they have a lot of process data, and you understand the statistical data and process control, these type of things in your second year. And then third year, that's really where you are now starting to narrow down, and you have interesting courses. And eventually in your final year, I think you can specialize in 4 different themes. One could be biomaterials theme, it could be a nanomaterials theme, it could be a manufacturing theme. I mean, manufacturing, of course, is a key component. And it could also be like a sustainability and sustainable materials processing theme, because today, whatever we want to do, sustainability is, of course, a key topic. I mean, we can't ignore sustainability.
Sure. Teresa, anything to add?
Yeah, so you get a taste of these themes in third year, and you have to go through the courses just a little bit, and you get to see what they're all about. And then in fourth year, you're choosing them for real, and you're choosing your stream. You can also take courses in the other streams for sure, but you will choose one stream. For example, I'm going into the manufacturing stream. I'm learning about forensic engineering, and I'm doing a lot of the fracture and failure mechanics of them.
Now, one of the characteristics of our program is that in first year, all students, regardless of their discipline, are going to be doing a design project. So in the case of materials, the students will be doing engineering strategies and practices. But going into your upper years, what are some of the more unique capstone projects that students do?
So see, if I can answer that, I have seen students doing interesting capstone projects. Like there could be I have seen students doing a project where there is like a seat for a space shuttle or a seat for an aeroplane, like a pilot seat, and they are trying to design that seat so that the pilot can be more comfortable, and at the same time it's mechanically robust so that it doesn't break. I have also seen students do projects related to designing like a metallurgical furnace to make sure the furnace is efficient, it is strong, it works at high temperatures. So I think you can, in your capstone project, since it's by nature multidisciplinary, you could be working on anything you really want. And in many of the courses also, you have the opportunity to do a project, and many times the students are proposing these interesting projects. So that's how it's very flexible.
Now, if we can go back to your first year, Teresa, what was your capstone, or sorry, what was your design project in first year? Do you remember?
Yeah, so I really liked that project. I was designing a bicycle-powered pump, And it goes back to sustainable design, and the client really wanted us to design a pump that used no electricity, used human power to transfer water from the river onto the mainland of her island. And so we went into the design process, the fluid calculations, the costing of all of that, and that was really fun for us. We managed to win the design project, and she really liked the project, and she wanted to implement it as well.
See, the reason I asked you to talk about your first year project is because the students who are listening right now, who may be in their last year of high school, probably don't know that that's the kind of stuff that they're actually going to be able to do here. Not eventually, but right away. They're actually going to dive in head first into design work in their first year.
Yeah.
Now, on a similar theme, we are consistently ranked as the top engineering school in Canada. All 4 of the major international rankings have us as #1 this year. And we are also recognized as North America's #1 university for startups. Can you give us examples of how students in materials have benefited from, for example, not just research but opportunities to take some of their innovations and turn them into business opportunities?
Well, I mean, I could answer that as a professor. I mean,
You go right ahead, yeah.
I started here 3 years ago, and before that, as I mentioned, I used to be in a consulting environment. And then I came here and I started working with a few graduate students, and I started my own startup gig on the side because, I mean, we have a lot of mining and metals and materials industry around the area in Canada, and they need help. And so the thing is that I think one of the important things here is that many of the professors here, they are very entrepreneurial in nature, and that's why the students who are going to eventually work with many of those, they would be also getting an entrepreneurial seeding inside, so they can do very good. And apart from that, many of our engineering students, they are also involved in different clubs and activities which are actually building certain things, and many of them actually convert those ideas into startups. So there is a lot of opportunity to do startup businesses in this area, and the university really encourages it. That's the other beautiful thing
Yeah,
about
for
it.
sure. And also to get involved in many different facets of school life. Have you been spending your free time during the program?
Oh, I did everything. I did everything from orchestra to Iron Dragons, which is a dragon boating club. I did that for 2 years. I joined the MSc Council. I was the class rep for a couple of years, and I ran events and all sorts of things. Yeah, I had a lot of fun.
And I think a lot of people who just heard the word orchestra were probably really happy because we tend to get a lot of students who want to go into engineering and also play an instrument.
Mhm.
We tend to attract a very musical group every year.
Yeah.
So, as you know, we also have a program called PEY, Professional Experience here, which students tend to do between their 3rd and 4th year, sometimes between their 2nd and 3rd year. 12 to 16-month program. Last year's average salary is about 50,000 Canadian dollars. The high end was actually 104,000 Canadian last year. What do students in materials engineering typically pursue for PEY? What kind of placements do they have?
So I've seen everything from getting accepted to Harvard for research to going into banking positions. We've had students go abroad to Japan for R&D, and then to Belgium and the outskirts of Europe for companies who are hiring materials engineers. There's also a big field in the simulation in the oil and also in the oil and gas industry. I myself worked at Celestica, which was a electronic manufacturing company here in the GTA, and I was working in the materials lab specifically for materials, doing quality and reliability assurance on electrical components that went into aerospace and defense, and startups who wanted to implement chips and stuff into their components. So I've seen everything. I think last year they had about 65% of our PEY students go in the outskirts of GTA, but you can also get Calgary and the Europe as well.
Sorry, what was I going to say? And after that, where do graduates of the program typically end up? I mean, how many go into industry? How many go into further research? What's your experience with that?
Well, I think especially most of the students, those who opt for the PEY, they usually often land up a job right away. I mean, doesn't take too long, and UFT is very well known, well recognized, and of course the students do very well during their PEY year. So that definitely that would be the majority part of the population going into industry. But then we also have a very good, very, let's say, motivated students who really want to do further research and want to learn more, and they end up going to grad school in the US, in Europe, in Australia. So, and many of them also stay here. Many of them go to other Canadian schools. So yeah, but I would still think that majority would go into the industry because of the PEY program, and I think that's certainly also a very good route.
And you already have your plans for after graduation, is that right?
That's right. So I accepted an offer from a technology consulting firm.
Are you in Toronto or?
Yeah, here in Toronto downtown, and I'll be working right away when I graduate.
Fantastic. And just to circle back to PEY, I mean, it's not a mandatory requirement for you to do PEY, but approximately 70% of our overall student population will do it, and 70% of those students will leave with a job offer in hand. So it's a great way to earn money, but also to get experience, establish contacts in industry, and that employment piece at the end is a really powerful complement as well. How did you decide where to do your PEY? What was the process that went into that?
So there's an application process, there's a portal, tons of jobs coming in and out every day. You're learning how to do your resume and cover letter, there's workshops to go for interviews and how to answer phone interviews and things like that. And basically I applied to the jobs that I wanted. So I specifically targeted materials lab positions, and I was really happy to receive a few interviews and eventually an offer, which I accepted.
So you didn't do it blind, is what you're saying. It was not a blind process for you.
No, at first I was applying everywhere, and then you come to realize that doesn't work. You gotta tailor your resume, you gotta tailor your cover letter, and you really gotta narrow down to what you want in the end. So that was a process, and then eventually it led me to the right call.
All right. Well, let's say that you had an opportunity now to tell prospective materials engineering students sort of one sort of takeaway piece from all. It's like if there was one thing you wanted them to remember, what would it be? And I say, you have this opportunity. Now you have this opportunity to do it right here for the camera. So what would your takeaway piece of wisdom be?
Me or Professor Knorr?
Knorr, let's start with you because you seem like you want to think about this for a second.
I do.
Yeah, and you were a student, so your opinion matters.
Absolutely.
It's important.
So Knorr, you start?
Yeah, well, look, I will say just one thing. It's a fantastic department, fantastic faculty, and we are by far the smallest department in the Faculty of Engineering. So the relation between teacher and student is very good. And I think that's a very enriching experience for me as a professor too. Like, I know most of my students by name, and I can help them, and I know them by name. So I think that's the one word: fantastic department.
Okay.
Marisa, we're back to you.
So coming to U of T, I was very afraid of not having a social life, but I got to experience social life right off the bat. From the first day of Frosh Week till I think my last day when I leave, I will be able to go out with my friends and be able to do everything I wanted to do in school. And that's why I say look into U of T, because you will have a social life, you will have a great education. If you join materials, you will be in a faculty that actually cares about their students and really wants them to succeed, wants them to be interested. And you will have fun.
And it's great to hear that from our students, because one thing we constantly say to students is that we have a very strong community, both in terms of academics, but in terms of that broader community as well. And that when you come here, it's expected that because you were involved in high school, that you're going to continue that involvement through here and help shape the engineering community at the University of Toronto. And it seems like you've done a pretty good job of that over the last 3.5 years. Any final words of wisdom?
Well, just to add to your point, I mean, U of T, great school. It's not only for studying. Studying is a big component, but all the social life, everything you learn around, many things you learn outside the classroom, and you have the facilities to do that. And I think, at least in our department, the professors really encourage. They wish to support the students. So I think one of the best choices you can make.
Exactly.
All right. Well, that's it from us. Again, if you have any admissions questions, my colleague has put our general email address into the chat, and you can drop us a line with anything that you want to know, not just about admissions, but about the school as well. Any follow-ups to the questions that were asked today and some of the answers that were given. Before we leave, though, we've been interrupted. We do have one question. Kenora, I think this one will go to you. The question is materials engineering a good base to go into nano engineering? You kind of touched on that.
I think that is the only base you can think of, because we are really learning in our courses and research about going into the atomic level and even below the atomic level. So I think if anybody wants to pursue like a fourth year specialization in nano, or even graduate school in some of the top schools in nanomaterials, I think materials is the way to go. I mean, there is no other alternative. I can't think of any other alternative.
We have some of the best facilities in our department as well. We've got several different microscopes that look into just that, the nano aspect of the material.
And like she mentioned, the microscopes, we recently got a huge Canadian Foundation of Innovation project
Okay.
with a bunch of very, very good microscopes, and students are trained on that. They can use it, so absolutely.
Looks like that question came in just under the wire. So back to what we were saying, thank you very much for tuning in. Any admissions related questions, please email them to us. Kenora, Parisa, thank you so much for coming in to join us this evening, and thank you for joining us this evening.
Thank you.
That's all from us. Have a great night or a great morning wherever you are. Take care,
Bye-bye.
everyone.